cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
What if we could bend the very fabric of reality? What if we could fold space and time like a piece of paper, bringing distant stars right to our doorstep? The idea of warping space-time, a staple of our favorite science fiction stories, isn't just a fantasy anymore. It's a concept deeply rooted in real physics, first unveiled over a century ago by the brilliant mind of Albert Einstein. He showed us that space and time are not separate, but are woven together into a single dynamic continuum. In this video, we're going to dive deep into this incredible idea. We'll explore the mind-bending physics behind space-time, break down how a warp drive might actually work, and examine whether humanity could one day use this technology to achieve the impossible, faster than light travel. So, buckle up, because we're about to take a journey to the very edge of what we know about the universe and explore how warping space-time could finally unlock our future among the stars. The journey from science fiction to science fact starts right now. To truly understand how we might warp space, we first need to change how we think about it. Space isn't just an empty void, a black backdrop for the planets and stars. According to Einstein's theory of general relativity, space and time are fused into a four-dimensional fabric called space-time. And this fabric isn't rigid. It's flexible, dynamic, and can be stretched, bent, and even compressed. Think of it like a giant cosmic trampoline. When you place a heavy object like a bowling ball in the center, it creates a dip, a curve in the fabric. This is exactly what massive objects like stars, planets, and especially black holes do to space-time. They curve it. And this curvature is what we experience as gravity. It's why planets orbit stars and why we're stuck to the surface of the Earth. Gravity isn't a mysterious force pulling us down. It's the shape of space-time itself, guiding our motion along its curves. Now, here's the revolutionary part. If massive objects can bend space-time naturally, what if we could learn to do it artificially? If we could generate our own controlled curvatures in this cosmic fabric, we wouldn't just be moving through space. We would be controlling the shape of reality itself. And that is the key to unlocking interstellar travel. So how do we go from bending space-time to building a starship? The most famous theoretical concept is called the Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994. Imagine our spaceship encased in a bubble of energy, a warp bubble. This bubble would manipulate space-time in a very specific way. In front of the ship, it would cause space-time to contract, pulling our destination closer. Simultaneously, behind the ship, it would cause space-time to expand, pushing our starting point further away. The incredible thing is, the spaceship inside the bubble isn't actually moving through space in the traditional sense. It's sitting perfectly still, protected within its pocket of flat, unwarped space-time. It's space itself that's moving around the ship, like a surfer riding a wave on the ocean. The surfer isn't moving faster than the wave. They are being carried by it. In the same way, the warp bubble would be a wave in the fabric of space-time, carrying the ship along for the ride. Because the ship itself isn't accelerating, the crew inside wouldn't feel any G-forces. They could cross vast cosmic distances in comfort without being crushed by extreme acceleration. This ingenious concept provides a theoretical loophole to one of physics' most fundamental rules. The ultimate speed limit of the universe is the speed of light. Albert Einstein's theories tell us that nothing with mass can ever reach it, let alone exceed it. As an object accelerates, its mass increases, and the energy required to speed it up further grows exponentially, becoming infinite at the speed of light. So, how does a warp drive get around this unbreakable law? Well, it cleverly sidesteps it. Remember, the ship inside the warp bubble is technically stationary. It's not breaking the light speed limit locally, within its own little patch of space. Instead, the bubble of warped space-time itself is what's moving, carrying the ship with it. And according to general relativity, there is no known limit to how fast space-time itself can expand or contract. The expansion of the universe right after the Big Bang at a rate far exceeding the speed of light. So, by creating a localized, controlled version of this expansion and contraction, the Alcubierre drive could propel a starship at an effective speed that is many times faster than light without ever violating local physics. This would slash interstellar travel times from tens of thousands of years to mere weeks or even days. The nearest star system, Proxima Centauri, could be reached in a matter of months instead of millennia. This is how we could finally break the light barrier and explore the galaxy. Now, before we get too excited and start packing our bags for Alpha Centauri, we need to talk about the immense challenges. The physics behind the Alcubierre drive is sound, but the engineering is, for now, completely beyond us. The biggest problem is energy. To create the kind of space-time curvature needed for a warp bubble, the theory calls for something truly exotic. Matter with negative mass, or more accurately, a negative energy density. This isn't antimatter, it's a hypothetical form of matter that would have bizarre properties, like pushing away from gravity instead of being pulled by it. It would be the fuel for our warp engine, creating the expansion of space behind the ship. The problem is, we have never directly observed or created stable exotic matter with these properties. Furthermore, the initial calculations for the Alcubierre drive suggested that it would require a staggering amount of this energy, more than the total mass energy of the entire observable universe. It was an impossibly high price tag. However, the story doesn't end there. In recent years, physicists have been refining the model. New research suggests that by changing the shape of the warp bubble, the energy requirements could be drastically reduced, perhaps to the mass of a large planet like Jupiter, or even less. It's still a colossal amount, but it is a move from the realm of the impossible to the merely extremely difficult. So, is anyone actually working on this? Is this all just theory on a whiteboard? Surprisingly, no. While we are nowhere near building a full-scale starship, the first baby steps are being taken. At NASA's EagleWorks laboratories, a team led by Dr. Harold Sunny, White has been conducting experiments to see if they can generate a microscopic warp field effect. Using a device called a White-Jude warp field interferometer, they are trying to measure incredibly tiny disturbances in space-time. The idea is to see if they can create a minuscule transient warp bubble in the lab just for a fraction of a second. These are incredibly sensitive and difficult experiments, and the results so far are preliminary and subject to debate within the scientific community. But the fact that they are happening at all is a monumental step. Independent research groups and labs around the world are also exploring the theoretical foundations, looking for new ways to reduce the energy requirements and sidestep the need for exotic matter. We are in the earliest days of this field, much like the Wright brothers tinkering with their first gliders. We are a long, long way from a fully functioning starship, but the journey has begun. What was once pure fantasy is now the subject of serious scientific inquiry and experimentation. Warping space-time represents more than just a faster way to travel. It represents a fundamental shift in our relationship with the cosmos. For all of human history, we have been bound to our planet, and our solar system has been our backyard. The stars have been distant, untouchable points of light, separated by distances so vast they are almost incomprehensible. A warp drive would change everything. It would be the key that unlocks the galaxy, transforming humanity from a single-planet species into a truly interstellar civilization. The challenges are enormous, perhaps the greatest scientific and engineering hurdles we will ever face. We may need to discover entirely new physics, new sources of energy, and new forms of matter. But history has shown us that what seems impossible today can become the reality of tomorrow. From splitting the atom to landing on the moon, we have consistently turned science fiction into fact. The dream of a warp drive is the ultimate expression of our exploratory spirit. One day, if we can solve this puzzle, a single warp bubble could launch us on a journey that will redefine humanity's place in the universe forever. The cosmos is waiting. Thank you so much for joining me on this journey to the edge of physics. If you enjoyed this exploration of warp drives and space-time, please hit that like button and consider subscribing to the channel for more deep dives into science and the future. And let me know in the comments below, if we had a warp drive tomorrow, where would you want to go first? Thanks for watching.